Welcome to my video where I'm going to show you how I made an electronic ignition for my 1971 Moto-Guzzi V7 Special. Only two components are needed, that's a hall sensor and an ignition box. The ignition box comes out of a Volkswagen from the 80s and 90s. They were used in very many models. It's very easy to find, reliable. And I found one at the scrappers for about $20 US. If you do that, be sure to get the connector with it. It has a 7-pin connector and it's nice to have. This system should work on all the older Guzzi which has the distributor in them. And in fact, if you want to convert a car or another type of vehicle, you can do so using the same techniques that I will show you here. I did this conversion during the coronavirus social distancing thing, so I tried to make use of what I had in my workshop. That means that there are no fancy bling bling or polished parts here. There will always be some kind of compromise when you do this kind of thing, and the only real cutting that had to be done was to make a slit in the distributor so that the hall sensor could slide in place there. That goes well into the hole which holds the spring for the points. However, it doesn't compromise the hole too much, so you can build it back to stock if you want to do that later. And that was kind of important to me because I wanted to have that possibility. Also, the original coil is still in place, and so there is only the two components that are a change of the original design. The hall sensor is made by Honeywell. It's easily available online. I bought mine off ebay.uk for about 20 British pounds. The model is called SR17J6 and it's only one of several variants that you can buy depending on your purpose. The sensor is very small and it's certainly needed because the distributor on the Guzzi is very small as well. There are 3 wires on it which all go to the ignition box, positive and negative, and a signal. The first thing you need to do is to make a plate to mount the sensor on. There is a ridge down in the distributor, and from that ridge up to the place where the sensor needs to sit should be 11.5 millimeter. I did not have such a plate with that dimension in my workshop, so I used 2 5mm aluminum plates and a small shim under the sensor. You can see that I use a couple of square brass nuts to hold the plate in place. Another thing that you can see is that the triggering plate is epoxied to the rotor. It also has a small pin locking it in place if the epoxy ever should come loose. We'll go more into the cutting and the degreeing of that plate later. When you have the distributor out on the table like this, it's a good idea to check the end slack. They are known for having a big end slack, and since the gap on the sensor, the hall sensor, is very limited, you need to get rid of that slack. So put a few spacers in there and you will be good to go. As you watch the disassembly and assembly of the distributor, I can say that I do advise you to use a new rotor and a new distributor cap. The distributor cap needs a small groove filed into it where it meets the sensor. The rotor obviously has the triggering plate epoxy to it and drilled in with a pin, but the pin will actually help you when you're going to replace it down the line by more easily finding the place where it needs to sit. Now, if you have a lathe, you could surely make just one plate rather than the 2 that I made, and find a easier solution than the square brass nuts that I used. But I kind of have fun using what I can find in my shop and making something useful out of it. And in fact, I'll be doing more of that in the future. So there are many ways to do this, and this is just one of them. And most of the components we use here is just car stuff from the 80s and 90s that just happen to work well for our application. The only precision thing, if you will, it's a triggering plate, which you have to match the two cylinders in firing, and we'll get into that in a moment, how I made mine. But before we'll do that, we'll have a look at the electrical schematics. I'll show you how to do the wiring. It's all very easy, it's only a few things that needs to be wired up. So even those who don't like doing electrics, it should be quite easy. Here's a small drawing that I made of how to connect the wiring. As you can see, the ignition unit has 7 places to put wires, but the number 7 is not in use. So the number 1 that goes to the negative side on the coil. Number 2 is the ground wire that goes to the frame. Number 3, that's the negative on the Hall sensor. Number 4, that's the positive wire that goes to the coil. And number 5, that's a positive on the Hall sensor. And number 6, that's the signal, that's the green one on the Hall sensor. And that's it, pretty easy. So here's the ignition unit with the plug for it. I made a few connectors on it so that it will fit in the bike. This here is for the Hall sensor, the 3 wires. This here, it's for the positive side of the coil. This is for the negative side of the coil. And this is just a ground wire that you ground in the frame of the bike. The color coding on this plug, or the wires on the plug, fits pretty good with what's already there on the sensor. The green one, that's always a signal. The black and the red, it's the positive. And the brown white, it's the negative. So if we go over to the bike to try to fit this, see that I have the ignition unit already in place, so we can just snap the plug in place. Here's the connector that goes to the Hall sensor, and the ground wire I will put up in here inside the frame. There's already another wire that's grounded there, so that should be good. So then we have only the 2 wires that goes to the coil. This thick one, it's on the negative side, together with where the tachometer go, and the thinner one goes to the plus side on the other side of the coil. And that's it. That's all the connections needed. One thing that is also a positive thing about this is that this ignition box, it will actually give a hotter spark than what was there from before. So I don't know exactly what it does other than that, but I know there are transistors and stuff in there. So I think that Volkswagen calls it electronic transistorized ignition with Hall sensor. So yeah. Okay, so let's look at the ignition events in our engine. Let's pretend for a moment that this is the pulley on the crank in the front of the engine. That means that we will have one cylinder here, we'll have another one here, and we'll have the crank pointer somewhere here. To keep this simple, let's say that this point here, 0, that's when the first cylinder has its ignition. So what happens, it ignites here at the timing mark. Let's pretend that this is 0. So the crank starts moving around first thing that happens, it will come up here on 90 degrees. Then it has run half a turn, that's 180 degrees. And when it comes up on the 270 degrees, that's when the second cylinder ignites. So the relationship between the ignition points of the two cylinders, that's 270 degrees, and that's important. Now, the distributor will run at half the speed of the engine, so in fact the timing plate that we need to put in here, it will need half the degrees of the 270. That goes to 135 degrees. So when we start making the plate that will run in our Hall sensor like this, we will need a 135 degree cut. And the important thing to remember is that the Hall sensor will give the signal to the coil when it exits, not when it comes into the metal plate. This here will obviously be cut out, right? And this will be cut out, so that you will be sitting with these two pieces. So when this comes in here, the coil will be activating, and when the Hall sensor leaves, or when the plate leaves the Hall sensor more rather, then the signal goes. So when you start grinding, you will need to grind on the exit points to actually move the timing points of the cylinder or of the ignition. So that's an important thing to remember. Now the 135 degrees, consider it's a starting point. When I begin make this, I will of course keep a little bit extra metal on each side so that I have something to grind on, because you know, there are many steps before the spark actually comes at the spark plug. So the only way to really verify is by a timing lamp. To just put it 135 degrees and think it's going to be all right, it's not going to cut it. So in order to have a good control of what's happening in the engine or in the ignition system, then you need to use a timing light on the both of the cylinder. You first set the number this cylinder, and you get the engine running on one cylinder, and then you take the timing lamp, you move it over to the second cylinder, and you can actually see where you are. So you need to take this in and out several times and grinding before you get it on the right timing mark. And that's another thing we need to talk about. You will need to make a second timing mark on the pulley so that you have so that you really know when the second cylinder is firing and if it's firing on the right time. That's because the relationship between the firing point of these two cylinders is, you know, it's cut into the plate, and once you get that right, then it's set forever. Okay, so let's look at the engine and how to make the second timing mark. So we have here the instruction manual, and we'll have a look at the picture here, which shows the crank pulley and the different markings that are on it. You can see here the pointer, which is on the engine casing, and as the crank rotates, these different markings all represent a certain point of ignition. The most important one that we are going to concentrate about, it's the C marking. That is the ignition point at idle. That's about 10 crank degrees. It doesn't really matter to us, but what we need to do is to make another one 270 degrees after when this has passed. So I'll show you that on the engine in a moment, but it was really dark, it was difficult to see, so that's why I'm showing you these markings here. So this B here, that's the top dead center, and so it's a second one after that. So because the top dead center, it's the last one that's going to pass here. So the ignitions, the different ignitions are all before top dead center. So this here, that's the important one, the number 2. Okay. So here we are at the engine. You can see the different markings. I tried to clean them up a little bit. That's the top dead center. That's the last one that passes through the pointer. That's the one that we want to concentrate on. That's the C marking. That's the idle ignition. So what we need to do is to find a way to copy that C mark over to 270 degrees and in the right direction as we're turning the engine. See, I made this small plate with a 90, every 90 degrees marking, just a cross actually. And I made a tight fit around the boss of the crank nut washer there. So when I put it on, it fits really tightly. I already done this actually, so this is just a demonstration on how I did it. And since the front fender and the front suspension is in the way, as you see, I'm holding the camera a little not straight, so it will look like I'm not doing a proper job there, but it's already taken care of. So as we now start to turn the engine in the correct direction, the first thing that happens is that we get about 90 degrees, and there is 180, and as you see, the 270 degree is coming up. You see that I already made a couple of notches there. I just took a file and I made some notches, and they will show up really well with the timing light when you start to test it out. So in the beginning, that marking will be way off, and as you take the plate in the distributor in and out and grinding it, you will get closer and closer. Since the distributor runs at half the speed of what the crank does, you actually have to grind quite a bit to see the result. So you should probably be able to grind yourself into place without really making any mistakes, because if you grind too much, then you need to start all over again with a new plate, because there's no way of going back. Then you will need to add metal, and that makes no sense. So the way I did it, I get it running on the number 1, and then I see where I'm at with the second one, and I grind a bit. Then I check both ignitions again. I check the first cylinder to see that that's where it was. Then I check the second one. I see how far away I am. Take it out, grind some more, and it doesn't really take long time. It's quite quick. And when you've done that, when you get it perfectly, then you epoxy and drill the timing plate to the rotor in the distributor, and then you're good to go. As I am demonstrating in this video, when I get the bike running, I will check the timing on the first cylinder. I know it's difficult to see because it's dark and I'm just using my cell phone for filming, but there I'm verifying the timing on the first cylinder, and then I'm moving it over for the second cylinder, and that should correspond with the second timing mark that we just made, which it does. So now the bike is running, it's running well, and yeah, that's it. So I've been driving my Guzzi around with the ignition system that I put together, and it has been working very nice. It's been a couple of weeks now. However, there is one last modification that I want to do, and I don't even remember how I began to read about this, but in one of the Volkswagen forums that I read, there was a guy that converted one older Volkswagen to this system, and he over time had fried the coil. And so I began reading a bit more about it, and it's supposed to be a special coil that is used with this system, or it's not a special coil, but it has a different resistance. So I'm gonna show you that by measuring first the Guzzi coil on the primary side, of course, and I don't know if you can see that here. Yeah, there it is, 4.2. And if you look at the coil, which is supposed to be for this system, let's see if I can do this with just one hand. Okay, so there's a proper connection, about 0.809, and that's a big difference. And it's too bad that the sticker here is worn out, but actually on the sticker it says that it's a coil for the TCI system, and that too tells me that this coil needs to go in the bike, because thinking about that you're risking of frying the coil and having a breakdown somewhere isn't really that useful. So I'll just put in the correct coil, and so if you're going hunting for these parts and you want to do this conversion, the best thing is just to find a parts car at the scrappers or somewhere, and just pull out the coil, pull out the ignition box and the plug. So then you have the three components that, well, the two components that are supposed to work together. The whole sensor, it doesn't matter because it's just a switch. So it's a different thing. But get the coil, and you have the components that are supposed to work together. So let's look at some parts numbers. First up, it's the coil. I forgot to mention that it does fit in the original Guzzi clamp on the bike, so it's a little bit longer, but it bolts right in there, and it fits very nice. One thing to remember is that the wire that goes out to the distributor, the high voltage wire, has a bit of a different connection in the coil than the old Guzzi coil has, so you will need to get a cable from the same car, and you can just cut it at the distributor end and put on the old plug there. Next is the 7-pin plug that goes into the ignition TCI unit. What's put up there is a Volkswagen number. I think that AMP makes them also, and so you can find it on the aftermarket if you're not able to source one from a vehicle. And last, it's the ignition box, the TCI unit. It was used in lots of different Volkswagen, Audis, and other brands too. So it will be pretty easy to find. There are some variations on it, and I know that some has 5 pins, and but you need to get the 7-pin version. That should and anyway, if you use the part number that I supplied here, you will be fine. And with that, we have come to the end of this video. It turned out to be longer than I really wanted it to be, and still we could have gone much deeper into the technical stuff, but I didn't think it was necessary. If you follow the techniques that I show you here, you will get a good and easy and reliable ignition system. Both the TCI unit and the Hall sensor, it's pretty easy to change if you should have a breakdown somewhere. But these things last years and years in the Volkswagens, and they were actually used in 4-cylinder vehicles, and we only have 2 cylinders. So in theory, the things have a lot less work to do in our bikes than they had from before, so they should last a long time. I will do a follow-up video on this at a later time. If there are questions, they can be written in the comments, and I will answer them as good as I can. And please give me a like, and maybe we'll see you on the road somewhere.